The idea of a tree data structure in its most generic sense is that we have a collection of objects. For the moment, let's call them nodes that have connections. They have links between each other. Well, okay, we already talked about a data structure made of multiple nodes and links when we talked about linked lists. But in a linked list, we always go from one node to a single specific next node, to the next node, to the next node. Even if we can traverse the list back and forth, this is a fixed sequence. But when we have a tree, the difference is that each node might link to one, or two, or more nodes. And while we could represent this visually in all sorts of confusing ways, the best visual representation is a tree structure. Now, how these objects are physically allocated in memory is unimportant. This is a logical data structure we're talking about. It's not about whether these are taking up contiguous areas in your RAM. It doesn't matter. This is a way for us to think about things and make sense of complexity. Now, let's get a few pieces of terminology down so we're all on the same page. As when using a linked list, there is always one specific starting node in a tree data structure. It's referred to as the root node. And yes, if this was a real tree, the root would be in the ground, but we usually draw them in this orientation. Now, this root node can itself contain a value, any object that you find useful. But also, as with linked lists, the root node will contain links to other nodes. In C++ and Objective-C, these links would be pointers. In other languages, they'll be object references. So these next nodes are referred to as child nodes. The root is the parent of both of these child nodes, and the root itself has no parent. But each of these child nodes can itself contain child nodes, and so on and so on. So this idea of parent and child nodes continues down the tree. So a node can be a parent and a child at the same time. This node B, for example, is a child of the root and also a parent of those below it, of its own child nodes. And child nodes with the same parent are called siblings. So the terminology here is not particularly bizarre. It's fairly understandable. We'll cover a couple of more words, including the idea that if we have a node with no children, that would be referred to as a leaf or leaf node. So this is enough terminology for the parts of the tree. Nothing too strange here. So I've drawn a tree structure here with no more than two child nodes for any parent. This is referred to as a binary tree. A binary tree is just a tree structure with a maximum of two child nodes from any other node. It doesn't have to be two. It could be none. It could be one, but never any more than two. If there's any more than two child nodes for any other node, it's not a binary tree anymore. Okay, so why is that important? Well, because binary trees are often used for implementing a wonderfully searchable structure called, not surprisingly, a binary search tree, or BST.